This is a dial caliper, named because, first of all, it has a dial, and a caliper allows a pair of clamped to close upon an object, much like a set of calipers do for measurement. Rulers, of which a machinist rule would be metal, this is yellow plastic to aid in visibility on film, are accurate to usually to about the 64th of an inch, which is less than a hundredth of an inch, roughly around 0.016 inches or 16,000th of an inch. Below that, which of course most of our applications for motor shimming, motor measurements are, we require something more accurate for measurement. That device is the dial caliper. And using a dial caliper, we really have the ability to measure distances merely by moving the caliper arm apart and measuring a distance. Now, in how to measure the distance, we really have several scales with a dial caliper. The first scale that we use down here gives us in tenths of an inch length, starting from 0 inches, going to 1 inch, and in between 10th, 20, 30ths, 8/10ths, all the way to 1 inch, 2-inch marking, etc. Comparing to a ruler, we can see that basically marks the same distance as a ruler. Now, in the measurement of an object, if we were to measure close to 1 inch distance, as we can see down here on the floor, 0 inches to 1 inch, and to measure this distance more directly, we would measure this as 0 to 1, and barely we see the 1 there, and not the next marking over, and not the 9 marking, so we know this is exactly 1 inch, 1.0, and we can see the scale reads over to here. If this were exactly an inch, our distance would look like this. So if we measure inches or measure on a caliper, we measure the location of this edge with respect to this edge in terms of all the way to 0. That's the 0 scale. As we move out a tenth, and we can zero our scale by, first of all, zeroing out a caliper, moving this dial and its associated number to give us a 0 reading. From the 0 reading, we roll out the caliper. One complete revolution gives us a tenth of an inch. A second complete revolution gives us 2/10ths of an inch. We can go all the way out to 10 revolutions, which would give us a complete inch. So in reading a dial, if we were to measure an object of, say, 1 inch, we would say 1.0, in this case, 1.001 inches. 001. This dial measures in terms of thousandths of an inch. So it goes from 0 all the way around past 90 to 100 thousandths of an inch, or one revolution around completely is 1/10th of an inch, according to scale. Measuring this square object in its size, we can use a ruler about 3/4 of an inch. About here, about the same 3/4 of an inch. But if that's not accurate enough for us, we can use a dial caliper by simply sliding the caliper apart, zeroing the top scale when this is completely closed, and then we open the caliper, place the block inside of the caliper, close the caliper, and our preferred place is down towards the end. And now we can read this caliper as going through the tenths of a mark. 1, 2, 3, 4, 5, 6, 7. So 0.753 0.753 inches. So this block is about 3/1000ths of an inch larger than the nominal 3/4 of an inch. Measuring the width of this block, certainly easy enough to do with a caliper by using the bottom grippers, as we saw just earlier. And notice here that we can sometimes get measurements. We measure a different face on a block, slightly different number. Like in this case, this is a 0.755 dimension, showing that this dimension width is about 2/1000ths of an inch different than the previous dimension that we measured. It does happen. It's almost impossible to carve an exact copy. But the next question is, what if we want to measure not the outside diameter, but the inside diameter of this cap? Simple enough with a caliper. Again, we're always pushing in, zeroing out. And the way we'll measure this is we use this part of the connection. Notice how we line up at 0? We come out a distance where this might represent a width of 3/4 of an inch. From this outside edge to this outside edge would measure the same distance. So we use this inside of the cup like so, with its edges inside. To measure inside diameter. Once we have the inside measured, we can look to see that our measurement winds up being 2.1234, 2.404, 2.404 inches. Lastly, what if I'm not interested in the outside diameter, inside diameter, but depth of the plastic? Not necessarily the thickness, which we use an outside caliper for, but I want to know the depth from the top edge to the inside plate of this cap. That's where you use, in the case of rolling out on the caliper, this edge sticking out. Where if I set this for 1 inch, it will be about 1 inch between those two legs, or if I'm measuring the inside diameters, 1 inch from outside edge to outside edge, or if I'm using my depth measurement, 1 inch from the bottom of the caliper to the bottom of the plug. So in measuring the depth of this cup, I would simply extend out my plug, push the caliper down until the bottom edge hits the top edge of this cup, while this part is on this bottom plastic. To come up with my depth reading, which in this case is 0.642 inches. So you can get the 0.642 inches.